Mars, once a distant dream, a mysterious red dot in the sky, has now become the focus of humanity's greatest ambition: to extend our reach beyond Earth and establish a new home on another world. The idea of colonizing Mars has captured our imagination for centuries, but with this ambition comes an immense challenge: surviving on a barren planet. In particular, one of the most vital hurdles to overcome is ensuring that we can grow food on Mars. Mars is a stark contrast to Earth in almost every way. Its landscape is inhospitable, its atmosphere is thin and lacking in oxygen, and its surface is constantly bombarded by cosmic radiation. Yet, the possibility of growing food in this hostile environment is no longer a fantasy. Thanks to groundbreaking research, innovations in space agriculture, and advancements in biotechnology, we are beginning to understand how to tackle these monumental challenges and build sustainable farming systems for the future of Mars exploration. In this journey, we will uncover the technical, scientific, and philosophical aspects of growing food on Mars. What are the challenges we face? What solutions are on the horizon? And what does the future of Martian agriculture look like in a world far removed from the fertile soils of Earth? Mars is often called the red planet because of its rusty-colored surface, but its true nature is far from hospitable. Unlike Earth, which is blessed with a diverse and rich biosphere, Mars offers an environment that is lifeless and unforgiving. Understanding its unique characteristics is crucial to understanding why growing food on Mars is such an incredible challenge. Mars has an atmosphere that is thin and primarily composed of carbon dioxide, with only trace amounts of nitrogen and oxygen. This makes it almost impossible for plants to thrive in the way they do on Earth. Plants rely on a nitrogen-rich atmosphere and sunlight to carry out photosynthesis, and Mars simply does not provide these critical resources in sufficient quantities. Temperatures on Mars are another obstacle. The planet's surface is subject to extreme fluctuations in temperature, often plummeting to below -100 degrees Fahrenheit, -73 degrees Celsius at night, while daytime temperatures hover just above freezing. These wide temperature swings make it difficult to maintain a stable environment for plants, which require consistent warmth to grow. The Martian soil also presents another formidable challenge. While it may seem like a fertile ground, the regolith, the loose, powdery soil on Mars, is not suitable for agriculture. It's composed of iron oxide, rust, dust, and rock fragments, and contains perchlorates, which are toxic chemicals that can disrupt plant metabolism. The presence of perchlorates means that the soil needs to be remediated before any earth plants can be grown. Otherwise, these chemicals would hinder plant growth, reduce crop yields, and potentially harm human health. Mars' atmosphere is only about 1% as thick as Earth's, which leaves its surface exposed to harsh ultraviolet, UV, rays, and cosmic radiation from space. Without an ozone layer to shield against these harmful rays, Mars presents a constant threat to life, both for humans and for plants. On Earth, our atmosphere blocks most harmful radiation, and plant life can thrive in protected ecosystems. However, on Mars, this lack of protection from radiation would cause plant DNA damage, stunt growth, and decrease yields. UV radiation is known to inhibit plant growth by breaking down vital cellular structures. The challenge, then, is creating sealed, radiation-shielded environments where plants can grow without suffering the damaging effects of cosmic radiation. To solve this problem, scientists propose using radiation-proof greenhouses that would incorporate specialized materials such as transparent metals, regolith shields, or polycarbonate films to filter out harmful radiation while allowing sunlight to penetrate. These greenhouses would not only need to keep the atmosphere at Earth-like pressure, but also protect against radiation, offering plants the shelter they need to thrive in a foreign world. Mars is notorious for its extreme temperatures, particularly during the Martian night. The planet experiences nightly drops of up to -195 degrees Fahrenheit, -125 degrees Celsius, while daytime temperatures can rise slightly above freezing. For crops that require consistent warmth, these dramatic fluctuations create an inhospitable environment. Building temperature-controlled greenhouses would be crucial to providing stable conditions for plants. These structures would need to be equipped with energy-efficient heating systems, potentially powered by solar energy, nuclear power, or geothermal energy sourced from below the Martian surface. Additionally, thermal insulation would need to be used to ensure that the heat stored during the Martian day is not lost during the long, cold nights. One potential solution could be the use of phase-change materials that store heat during the day and release it at night to regulate temperatures within the greenhouse. Because the soil on Mars is not suitable for plant growth, scientists have turned to soil-free farming systems, such as hydroponics and aeroponics. Both techniques allow crops to be grown without the need for traditional soil, providing a sustainable solution for Mars' lack of fertile land. Hydroponics involves growing plants in a water-based solution where the roots are submerged in water enriched with essential nutrients. This method can reduce water usage by up to 90% compared to traditional farming, making it ideal for the limited water resources on Mars. Aeroponics, on the other hand, is a more advanced form of hydroponics where the roots of plants are suspended in air and misted with water and nutrients. This method requires even less water than hydroponics, making it an efficient choice for the Martian environment. Both systems can be integrated into sealed, controlled environment farms, where astronauts or future settlers could grow a variety of crops, including lettuce, tomatoes, and herbs. Additionally, vertical farming techniques could be employed to maximize space efficiency, stacking crops in layers to create high-yield systems within confined habitats. While hydroponics and aeroponics can solve the soil issue, genetically modified (GM) plants could be the key to creating crops that can withstand Mars' harsh environmental conditions. Through CRISPR gene editing or other biotechnology tools, scientists can enhance plants to be more resistant to cold temperatures, drought, high radiation, and low atmospheric pressure. For instance, researchers could engineer plants to have enhanced cold resistance so they can survive freezing Martian nights. Additionally, plants could be modified to fix nitrogen from the Martian atmosphere, enabling them to grow without the need for Earth-based fertilizers. Another exciting possibility is creating drought-resistant plants that can thrive with minimal water, allowing them to survive on the limited water resources available on Mars. These engineered crops could be tailored to the specific nutrients available in Martian soil or hydroponic systems, ensuring that the plants have all they need to grow. The concept of closed-loop ecosystems is key to making Martian farming sustainable. In these systems, waste from humans, animals, and plants is recycled into usable resources. For example, carbon dioxide exhaled by humans could be absorbed by plants, which would then produce the oxygen needed for humans to breathe. NASA has already conducted experiments in biodome environments here on Earth, such as the Biosphere 2 project, where researchers tried to create a sealed environment to simulate the conditions of a Martian habitat. These experiments provide valuable insights into how we can create self-sustaining ecosystems on Mars, where food, water, air, and waste are continuously recycled in a balanced system. In the long run, this type of closed-loop agricultural system could allow Mars settlers to grow all the food they need without relying on resupply missions from Earth. It could even be extended to fish farms or insect farming, providing protein-rich food sources in addition to crops like vegetables and fruits. The dream of growing food on Mars is a monumental task, but it is within our reach. As we continue to send rovers, landers, and orbiters to Mars, our understanding of the planet deepens. With every new discovery and technological advancement, we come closer to creating a sustainable, thriving agricultural system that will support long-term human habitation on the Red Planet. Whether through hydroponics, genetically engineered crops, or closed-loop ecosystems, the solutions we develop on Earth will be the foundation for life on Mars. By overcoming the environmental challenges and adapting agricultural practices to the Martian landscape, we will not only enable the survival of future Martian colonists, but also bring humanity one step closer to becoming an interplanetary species. The question is no longer if we can grow food on Mars. It's how we can grow enough to sustain life and eventually thrive. As we embark on this new frontier, the future of farming in space is bound to reshape our understanding of agriculture, technology, and human resilience.